I'd love to start by just looking you over, doing some palpation, and looking for areas of tension or stiffness in your body, if you don't mind. Okay, so let's start right up here with the head. My name is Calliope, and after this little exploratory venture here, which, yeah, we've got quite a bit of tension here in the back of the head, as well as the back of the neck here. But after we figure out what we really need to work on, the shoulders, chest, then we are going to be doing some massage. I'm just going to take your arm here so I can kind of move it around, rotate it if need be. We're just going to pick and choose from different modalities, just depending on what would work best for, I'm going to take this arm here, what would work best for your circumstances. Okay, so chest, and let's look at the legs here. It seems pretty tight. Do you stand on your feet a lot? Yeah. Okay. Can I see your feet? Let's take a peek at those. Okay. So we do have some swelling here in the ankles and the top of the feet, which, if you stand on your feet a lot, that doesn't surprise me. So, okay. Where do we want to start? I think maybe a top-down approach would be good. So, let's look at your head here. Let me just see. So, a lot of times, if you have tension in the back of your head, it's often related to eye strain and neck stiffness. Generally working at a computer or being on your phone a lot. Okay, how is this pressure? Alright, I'm just trying to unwind things a bit. So our aim is to match the techniques of whatever is appropriate to your particular issue. So for example, if we were doing just Thai massage, we would have to work on your issues in the context of Thai massage, which is a lot of stretching. You can do some kneading and whatnot. But what if you need a little more of a deep tissue approach? What if you need there's so many types of massage, ranging from the general Swedish, which is also known as classic massage, to indigenous practices like lomi lomi. A lot of cultures have their own style of massage. Just looking at the neck and where it comes up into the head here. Yeah, this is pretty rough here. Okay, so I think for this area, I'm gonna need more of a firmer touch. So let me know if it's too much, but this one's gonna be a little more on the therapeutic side than for relaxation. Good. Let's see, so where this connects with the occiput here. Yeah, that's real tight there. Okay, let's try some pressure here. I'm going to press in, and we're going to wait for muscle fibers to start relaxing. Okay, and then just massage that out a bit. Okay, press. This is really good for those real tender knots. So if your back is anything like that, we might be pulling out the trigger point, pressing and release. Okay, so we'll give that some time. And let me, I'm just going to adjust your clothing here. See what we got in the shoulder, into the arm, into the chest. This whole area plus the neck is all very interconnected. Okay, I think I want to start. Let's see if we can loosen things up with some stretching. So I'm going to pull your shoulders in and push them down. We're just going to stretch for a moment. Okay, bring them in, press them down. Okay, and bring them in, press them down. Good. So what I was doing was bringing them forward and pressing them down, and you can feel that stretch on the back of the rotator cuff there, all those muscles. And now we're going to bring it back and press down. And that way you'll feel some stretch in this general area. So bring it back, press down. Might be manhandling you a little bit. Okay, and roll back, press down. Good. And roll back, press down. Okay, let me grab your arm, and I'm just going to give it a few tugs. the other arm. Good. Okay. Let's grab both arms and I'm going to pull back. And let go. Pull back. Let go. And pull back. Let go. Okay, you can just let your arms go limp there. And let's definitely loosen things up. But I actually want to try something with you if you don't mind. Okay, so I've seen in Eastern Asian massage and body work that a lot of people will use stronger and more pointed pressure, but diffuse it with a towel. So they can work pretty deep, but it doesn't hurt the client. So I'm just going to put this on the chest and the shoulders. And see if we can really use some pressure in there. And let me know if it's too much. Good. We're going to try to lengthen these fibers a bit, because if your shoulders are rolled forward, these will shorten and the posterior muscles will lengthen in response, and that's not what we want. So I'm a bit of a yapper. I like to chat with my clients about things that maybe they really haven't thought about much of, or little fun facts, things of that sort. Just things that they may walk away with a little more, maybe interest in something. Or even if not interest, then a little bit more knowledge. And in particular, I like to keep my finger on the pulse on news of human evolution. And this year we've been eating good. We've had a lot. And especially the last couple of months has been pretty great. I mean, the start of the year was a lot of bangers. And then we had a bit of a pause. And then it came back around again. Okay, I'm just going to adjust our towel here. See if we can also get up a little bit towards the neck. So, some real interesting news on the human evolution front. We have essentially verified, I mean, there's a study published about it where scientists had tested this hypothesis, but there was a Neanderthal tooth that was found that had a hole in it that looked like it had been drilled. And this was 60,000 years old. Much older than the first instance of dentistry in Homo sapiens. bones. But in the study, the scientists said that they tested human teeth, multiple human teeth, to see what could make the hole in the Neanderthal tooth. Okay, I'm just going to take this off and put this to the side. Let's see. It's a little bit better. That'll be useful when we work on the back. Let me see your arm. I'm just going to stretch and move this, so bring it across your body here. So what they found was your most likely hypothesis was that the tooth was intentionally drilled. Okay, I'm going to bend at the elbow here. And in the fossil site, they found tools made of jasper that absolutely could have fit the bill for... Okay, I'm just going to turn your arm. We're going to stretch this way. Tools that could have absolutely fit the bill. Okay. Let's get into the deltoid here. What was even better was that when examined, the tooth had the hole, but it also was not a new hole by any means. It didn't seem to occur after death. It didn't seem to occur right before death, because there were numerous chew marks that were changing the hole in the tooth, which suggests that the Neanderthal ate quite a bit after that, and thus lived quite a bit longer after the tooth was drilled. So, first instance of intentional dentistry 60,000 years ago, and was done by a Neanderthal. Just gonna work with your hand a bit here. Stretch it. Knead into it. And Neanderthals have really, over the last few years in particular, gotten some good press. I mean, especially since we sequenced the DNA back in 2010, was it? But there was a study released in the PNAS journal in April 2026. Okay, I'm just going to stretch and move your hand and wrist. There was a study published that posits that Neanderthal cognitive ability was essentially the same as ours and was well within the variability of our own species. So it was thought that maybe possibly Neanderthals died out because they couldn't think as well as us, they couldn't plan as well, their executive function might have been worse, that sort of thing. Like we just outsmarted them. Okay, I'm going to pull on your arm here. Good. Get a good stretch in there. But more and more, that seems to not be the case. And Neanderthals actually had bigger brains than we did, which was also another hypothesis for why they might have died out, because brains are metabolically very hungry. They take a lot of calories to maintain, and the bigger the brain, the bigger the brain, the more calories you need. And in an area where you are a hunter-gatherer, you're foraging and hunting, and we don't know the exact diet of Neanderthals. It seems to be meat heavy, but that's a lot of meat you need to eat. Okay, I'm just gonna pull forward here. So, maybe is it that the bigger brain was a disadvantage? Which could still possibly be on the table. I mean, it's really going to be hard to answer anything definitively. Okay, I'm going to pull your arm out here. But I had also read something. Just the title of the article, not the article itself. But it was something about how Homo sapiens brains are getting smaller, and most likely that's a thing of organization. So the more efficient and organized a brain can be, the smaller it can be, the less energy it needs, that sort of thing. So brain size doesn't necessarily mean very much at all. But it seems to pop up more and more that Neanderthals were on our level, basically. That we know they had language, they had the capability of it, and it likely was not as complex as ours in terms of sound. They couldn't make all the sounds that we can. And then there's also the Homo erectus question of language, which has been going on for a long time. I read one article positing that Homo erectus had complex language that was written in 1998, and then another one that was written this month. Very long span. So the seafaring inference has gotten a lot of mileage. But it seems that here, bringing the shoulders in a little bit. Let's fix that before I work on the hands. There we go. It seems that more and more what gets pointed to as the demise of the Neanderthals is not that they died out, but that they got subsumed into Homo sapiens. That we interbred enough that they were just genetically overwhelmed and just became us, basically. Where, there were many more Homo sapiens than there were Neanderthals. Neanderthals, there weren't very many at one time. And then you have a whole bunch of Homo sapiens, and you have children, they have children with Homo sapiens, and Homo sapiens eventually just kind of dominate the reproductive landscape. So they don't necessarily go extinct, they just become part of us. Okay, we're going to do some stretching of the wrist here. Which I like to think of that. I mean, that's a much softer approach, I suppose. It also is much less tragic. You know, instead of us taking them to the brink of extinction or anything like that, like they just became part of us. I'm going to do some rotation here. But the most exciting news that I texted anybody I've ever discussed human evolution with, and I was like, I've been saying all year that I can't wait until Homo erectus gets sequenced, and lo and behold, for the first time ever, genetic material from Homo erectus has been sequenced. And it was taken from proteins. And that is a type of science known as proteomics or paleoproteomics. Okay. Alright, let's check in shoulders, chest. Okay, I'm gonna have you turn around real quick. We're gonna look at the back of the head, the back, the shoulders, that sort of thing. Okay, good. Let's see what we've got going on in here. So, proteins are much more stable than DNA is. The oldest DNA we've ever gotten from an animal is 1 million years old. And it is from a mammoth that was in Siberia, in which the soft tissue was still preserved. I believe even the blood was still present. So you need very special circumstances, because in a dry, hot environment like the desert, or a hot, humid environment like the rainforest, DNA does not last very long. You're talking thousands to tens of thousands of years. Okay, I'm gonna grab your arms and I'm gonna pull them back. Just like that. Okay. Pull. Good, and pull. Okay. I'm gonna leave your arms alone now. Alright, let's see what we got. But proteins, proteomics is becoming invaluable in those instances where we have no DNA to sequence, but we have proteins. So you can still get some genetic material off of them. So in this study, 6 Homo erectus individuals that were all around 400,000 years old had proteins extracted from their tooth enamel. And we found some very, very cool things. Okay, let's bring out this bad boy. Get you all situated. Okay. There. So, one amino acid variant they found, and amino acids are the building blocks of proteins. One amino acid variant found was present in all Homo erectus individuals that they tested, and it was linked to a variant in Denisovan populations, which also got passed on to some Homo sapiens that have Denisovan DNA in them. So we have a direct link from Homo sapiens to Denisovans to Homo erectus. And the most compelling piece of evidence, the coolest part, is one of the other amino acid variants was found only in Homo erectus. No other types of human. Not one. So what this means is we now have a way to determine who is Homo erectus. And why this is important, why that sounds maybe a bit odd. There is a fun little conundrum called the muddle in the middle. The muddle in the middle Pleistocene, which has confounded scientists for years. Where, at the time, you have 4 types of humans that exist all at the same time in the same areas. You have Homo sapiens, you have Denisovans, Neanderthals, late surviving Homo erectus. And I'm pretty sure it's just the Asian populations of Homo erectus. So you have Homo erectus sensu lato, which means in a broad sense, and that can be Homo erectus from Africa, from Dmanisi, Georgia, and from Asia. Those are the main populations. If you are not a grouper or a lumper and you are a splitter, then you split Homo erectus into Homo ergaster, the African population, Homo georgicus, the Dmanisi population, and Homo erectus sensu stricto, the Asian population. So, the muddle in the middle is trying to figure out how everybody is related to each other. And there's one of the problems with that is because everybody lived about the same time and they lived around in the same place. You get a lot of intermixing between human species. And you end up with specimens that have a mixture of characteristics. One of my favorite specimens, I can't remember, is it the Maba man or the Dali man? One of them has characteristics from all 4 populations. So then you're trying to figure out where one species ends and where one begins. I'm going to reposition this here. There we go. So evolution is an extremely slow process. And if you don't have any intermixing, you can tell much easier the very slow transitional path an organism will take to get to their most modern counterpart. When you have constant intermixing, you are introducing a lot of genetic diversity all at once, and you don't know what the organism is going to hold on to and what it's going to get rid of. So you end up with specimens that look like they have Denisovan and Neanderthal characteristics, Homo sapiens and Neanderthal, Homo sapiens and Denisovan, Homo erectus, and this, that, and the other. It's a big old mess. It's a big old mess. But So now they can tell, I mean, should this be replicable with many other Homo erectus specimens, they can now tell for sure who is who. We have too many fossils in the Pleistocene area, and that's part of the muddle in the middle too, is that we just don't know who belongs to who, because 4 groups in the same time, same place, that share a lot of characteristics, that can be pretty difficult. But if you find that this individual species has one specific marker, well, that changes the game a little bit. Okay, how are we doing on the low back here? Okay, pressure's okay. Okay, let me bring out the towel a bit. But yeah, the current prevailing hypothesis is that Homo erectus begets Homo heidelbergensis, which is the last common ancestor of Denisovans, Neanderthals, and Homo sapiens. But Homo erectus outlives Homo heidelbergensis because Homo erectus was simply on another level. I mean, it is completely absurd how long that organism was around. I mean, it was around the same time as the very beginning of the genus, and it was around up until very close to the current point of the genus. That's a lot. But it's thought that maybe, and this is a hypothesis I don't know if we'll ever figure out. Let's get this guy right down here. I don't know if we'll ever figure out the seafaring question, because Homo erectus ends up in islands very far from the mainland. However, sea levels were different. That being said, even with the sea levels being much lower, there are still places they couldn't have gotten to without some kind of sea craft. Whether they built it themselves or it was a naturally made raft, like of vegetation, that's the question we don't know. So, did Homo erectus use boats? Did they make them? Did they have them? And if they got to these places, that's what the seafaring inference is. If they managed to get to these places themselves, then that means that they would have had to have advanced cognitive abilities as well as language. And I don't know if I'll ever figure that one out. I'm just using my knuckles here to smooth everything out. So that's a big question. I don't know that I really have an opinion one way or another. I think in terms of anatomy and whatnot, they probably had rudimentary language. I mean, you see language in other species today. I think, is it bonobos, maybe? I don't think it's chimpanzees, but maybe it's bonobos. They have a rather complex language of different sounds. They have grammar. You know, birds have all different kinds of calls. I mean, even plants have pheromones that they release when you mow the lawn. that are basically like, help, I'm being murdered. So I think language, I think the definitions will have to be really scrutinized before we say one way or another. And I don't know if we'll ever truly know. So I'm gonna have you flip back around and we're gonna look at your legs. Okay? Alright, this is gonna be, yeah, we're gonna have to do some stretching here. I mean, it would be super cool, and I'm not doubting necessarily that Erectus had language. I just don't think it was as complex as Neanderthals, let alone H. sapiens. But what I haven't heard is about Denisovans in language. I mean, we have their DNA sequenced. So do they have the genes that are associated with language? And what does the anatomy look like? Would they have language on the same level of Neanderthal? Better? Worse? But what I'm really pleased about is this reduction of human and Homo sapiens exceptionalism. You see it a lot in the beginning of human evolution and anthropology, where, they didn't have many fossils yet, and we didn't know what anatomically you need for language, what kind of genes you need. And I mean, the stereotype for a very long time was that Neanderthals were big, bumbling, stupid cavemen, when they probably were just on the same level that we were. And they had bigger brains than we did. I mean, if you're talking about brain size equals intelligence, I don't understand that part. That doesn't make any sense. Okay. But the more fossils we get and the more we learn, the more that, it's kind of like the idea you see in science shows a lot, history shows and whatnot, where people are just so fascinated, like, oh, these people from 7,000 years ago managed this engineering feat. Like, yeah, they're just as intelligent as we are, if not more, because they had to figure out this themselves. They didn't have writing systems, so you could really only pass down knowledge from teaching and oral tradition. I mean, personally, even Homo habilis probably is much smarter than I am, because if I got put in the savannah, I wouldn't last 2 days. I wouldn't know what to eat, how to process plants, how to get away from predators. I wouldn't know any of that. How to build a shelter. I mean, you have to factor ability into intelligence, really. But one particular instance of human exceptionalism, human the genus. Okay, let's get into the calf muscles here. Human genus exceptionalism is Paranthropus. Big eye roll for Paranthropus. I mean, just look it up. Look up Paranthropus. You're just gonna be like, ugh. I have bias. I'm trying to get rid of it, but I have bias. Okay, on the other side here. So Paranthropus is what you get when you have a human specialist, basically. So the human genus is a generalist genus. Paranthropus is specialist. What that means is a generalist can have a more varied diet and can survive in a wider array of environments. Humans are a tropical species, and yet we live on Antarctica, in space, in the hottest places imaginable. Paranthropus, as a specialist rather, has a limited diet and a limited number of conditions it can live in. So when Australopithecus evolves into the Homo genus and the Paranthropus genus, you have the Homo genus, which has a bigger brain and survives much longer and is seen as much more intelligent. And then you have Paranthropus, which is the big, dumb, great ape. And there was a precedent that if you have a fossil site with Paranthropus and tools, but you also have someone from the Homo genus, even Homo habilis, then you attribute the tool use to Homo, not Paranthropus. Okay, can I see your feet? Alright, we're going to get into this. Let's do a bit of stretching here. And if you had a fossil site where you had Paranthropus and tools, but no Homo, you just attributed it to Homo, but just said that the fossils disappeared because Paranthropus couldn't use tools. It doesn't matter that tool use is attributed to even before Paranthropus with either Australopithecus or Kenyanthropus. That part doesn't matter. It only matters that Paranthropus is the big, dumb, great ape. But then, recently, we found fossils of Paranthropus that had partial hand bones, I believe. We'd never had the hands before. And Paranthropus, based on its hand anatomy, absolutely could have used tools. So now people are rethinking Paranthropus. Okay, let's go ahead and rotate this. But that was, I feel bad for Paranthropus. It gets the short end of the stick. And I'm still rather biased. I look at Paranthropus and I'm like, no. Not that one. But, I mean, really, I think it's so funny in kind of a sad way, that Paranthropus could not have any tool use attributed to it by people who do this for a living. Other foot. Okay. You know, I mean, we've learned more and more that everything is so much more intelligent than we give it credit for. And then we're like, but this organism cannot possibly use tools. I mean, birds use tools, cows use tools. That's very silly. But more and more, I think we're learning that there was just so much more intelligence in everything. I mean, there had to be, right? Just because something goes extinct doesn't mean that it was stupid. especially considering Homo erectus was around for like almost 2 million years. You gotta be doing something right. Just working into the foot here. But yeah, I hope more and more that we find things that refute this idea that because Homo sapiens won the evolution game, that we were the only smart organisms. Okay, just giving a few squeezes here. Okay. Set your foot back down. Okay, let's just check on. Okay, that's a lot softer. Everything's a lot more loose here. Okay, I'm gonna give your arms the last couple of tugs and a couple shakes. And one last one. There we go. Okay. Well, that'll be that. Is there any area you feel like I missed, like you need a little bit more? Okay, wonderful. Well, I'd like to thank you so much for coming and getting this massage here, listening to the Yap Master about human evolution. I hope you have a whale of a day and a good rest of your night.